In this last video on logs, what we're going to do is we're going to see how we can find out what the formula connecting two things is by basically plotting a log against log or log against x graph. So basically what we're going to do is we're going to turn this sort of thing by using logarithmic scales into a straight line graph. If you just listen, then we'll go through how we do it with this one. This is the first sort we're going to do. It's where y equals kx to the power b. Yeah, so something like y equals 5x squared. How we could deduce that sort of formula from information given. Okay, what we're going to do with this, if I take logs of both sides of this formula, we have log to the base a of y equals log to the base a of k, which is your constant, x to the power b, and b is a constant as well. If you remember from the rules of logs, when we multiply in a log, it's the same as adding two separate logs together. So I'm keeping this just like that. And look, that's going to become log to the base a of x to the power b plus log to the base a of k. Okay, the other thing we know is when we raise to a power inside a log, it's the same as multiplying the log. So this thing would become log to the base a of y equals b log to the base a of x plus log to the base a of k. Okay, now if I plot log y on the y-axis, I'm going to use a capital Y to represent log y, okay, against log x, so I'm going to use a capital for that. We can see that this, if we're doing log y against log x, would give us a straight line equation, where the gradient of the line, okay, is equal to the power b, and where it crosses the y-intercept, so we've got the gradient would be equal to b, and we've got that c equals log to the base a of k, or because we're trying to work out k, that's going to be a to the power c. Okay, so if we plot log y against log x, we will get a straight line graph. So for example, if I was looking at this, log y against log x, yeah, if it crosses there at c and it's got a gradient of m, c, well, we've got k equals a to the power c, and we've got b equals the gradient of the line. So we can use that. Look, if I've got this one, look, it's log to the base 10. So first of all, I know that k would be equal to 10 to the power 2, wouldn't it? Look, crosses at 2, so it's 10 to the power 2. See, comparing this bit here. And we've also got that the gradient of the line is the same as the power. So you've got b equals a half. So our formula from this would be y equals, well, 10 squared is 100. So it's going to be 100 x to the power a half. Okay, because we're basically saying, look, if we plot log y, that's capital Y, against log x, we've got mx plus c, so m was equal to b, and c was equal to log to the base a of k. So as it's k, we're after k is a to the power c. Okay, so if it's log y against log x, we suspect a formula like this one, and we work out what the variables are by doing this. Okay, and this is why. What we're going to look at in the next example is a similar thing, but this time it's when we've got an exponential equation. So we're going to go through that one next. This time round we've got an exponential. It's k as a constant, so it's k times b to the power x. So we need to find out what k and b are. So same as last time, I'm going to take the log of both sides. Remember, multiplying we add, so that bit's the same. Okay, so that bit's the same, but look, this time it is the x, not log x, isn't it? So it's just x times log to the base a of b. Yeah, because x was the power, so it comes to the front. So this time I want to plot log y, which is we write as capital Y. Yeah. Now, this time it's against x, because it's not log x, it's just x. Look, see? X. So if you see log of y against x, then what you've got is you've got an exponential equation, so it's of that kind. Okay, so this time the gradient is equal to log to the base a of b. So as we wanted b, remember b is the power, it's going to be a to the power m. Okay, and as before, c is still log to the base a of k. Remember we wanted k, so k is a to the power c. So if it's an exponential one, that's the way we do it. And you'll spot it's an exponential by seeing it's log to the base a of y against x. Because if you take log of both sides, that's what it gives you, which we can equate to that. Okay, so let's look at this. So if we looked at that one again, let's just write down what we've got. We've got that the gradient is equal to log to the base a of b. So b is a to the power m, and we've got that c is log to the base a of k, so k was a to the power c. Right, here the base is 8, but we don't have the gradient yet. The gradient, look, it goes down 1 for across 3, so that's minus a third. Okay, remember what we said? The gradient, so b is equal to base of the log, which is 8, that was a there, 8, to the power minus a third. Now if you remember, a third is the cube root of 8 is 2, and the minus means 1 over. So that's just 1 over 2, a half. Okay, k was equal to 1, c was equal to 1, so you've got k is 8 to the power 1, which is 8. So here our equation is y equals 8 times a half to the power x. Okay? And that would be the missing terms there. A little bit tricky, but if you look at that, okay, you've got basically a short exercise where you're given things like this and asked to come up with the equation. Okay, there's a short exercise on each. Okay, that's y equals k x to the power b and y equals k b to the power x. And as I said, this is how you do them. Have a good day.